Yeah, remember, learning outcome is important. Okay, learning outcome is important. It's where we set the question. I'm not sure you already received the student evaluation form. Yeah, so fill in and you can give a high score for this module. Uh, okay, um, we continue. So chapter 7 is more on the process and how to develop the products. So we learn about, and we're referring to this textbook lah. Referring to this textbook. If you want to know more about the particular specific topic, you refer to either of these two lah, the textbook. Okay. Okay. I'll go quite fast. Go fast. Okay. First, during the design process, what is the effective process? Usually, we follow the triangular. Uh, cost, time, and customer requirement. This triangular is very important. Cost, time, customer requirement, or specification, or performance. Okay, and this triangular is important. So, effective design process have to meet what customer want, have to be the simplest and least costly manner, same like your water rocket projects, right? You should be able to operate according to what customer want. Least costly means it's meet the cost requirement. In your case, maximum is 50 ringgit. Okay. So if your equipment, like for example, your water pump, not water pump, your pressure pump costs more than 50 ringgit, mitigate the cost by putting rental or you borrow from friend or loan from friend. Okay. So this is this module actually want to expose you how to manage project and come out with come out with the product development. At least you have a general idea. Reduce time required, also time, and minimize revision necessary. So this one is when you start the project, we try to minimize changes from the time start to end. Okay, you learn about the network already, right? And you learn about critical path. So if you have revision, one of the component will change time. So the Rubik's, the 6 space there, if one of the space change, overall will change, right? So it will affect the numbers in the front and also at the back. Okay, so we don't want that. This is an important chart. This is an important chart. Come out every semester. Question number 4, final exam. Okay, you need to memorize this one. Okay, this alone, maybe this chart, maybe 5 marks. But the body of the elaboration, the one question is 25 marks. This one is 5 marks. You draw this one, 5 marks. Then the rest of 20 marks, you elaborate using your diagram. Okay, it means without diagram, you elaborate, I will just give you effort marks, 2 marks. Means you don't know what you are talking about. You just write an essay to me. Okay. So without chart, you write essay. Yes, I can still mark, but your sequence might wrong. When you sequence wrong, it's not the design process. You jumping here and there. Yeah. So important for today. This chart is your life jacket. Die also need to memorize. Why? Because this chart answer CL4, learning outcome number 4. You need to know how to develop a project, a prototype. So there are four main, can say five lah, five main process. First one is idea generation. Second one is feasibility studies. The third one is rapid prototyping. The fourth is pilot run and final test. After the pilot run and pilot test is new product launch. So this sequence will apply to your water rocket projects also. Okay. When you're answering question 4, I'll look at what is your input, what is your output when you're answering the question. Okay. When you write the paragraph, for example, paragraph for the idea generation, you need to tell me what is your input for the first process. Okay, your essay write, first stage of the design process is the idea generation. The input of this first process will be the one that you see on the diagram. You elaborate on the diagram. And the output after all the input is what? Referring to the diagram. Okay, you repeat the same process, same way of answering the question. Okay, means the structure of your answer in one paragraph. What we expected is you mention the process first. After the process, you mention what is your input into the process. Okay, then what is the output? Okay, so this is the first diagram, first graph. So from here, you have how many input? How many input? 7. 7 input. Idea generation means before you start products, you need to know how to develop the products. All right. Now, for example, your water rocket projects. Idea generation, you go through marketing. You go to the marketing department and ask them, how do we sell, or what is the current market needs? All right. So in your quiz number 4, you have went through the textbook chapter 3, so you know how you gather the customer needs. All right. So you go to the marketing and you ask for the latest market needs. Second input will be the design firm, right? So just now the marketing, I take the water rocket projects as your example. So you go to the marketing department or you go to the functional managers component or layer. You go to the FM marketing department. All these are FM, functional managers level. So or specific department. You go to the marketing and then you get you ask them for info. Can you give me what is the latest water rocket trend, or what is our competitors and all these things? Okay. Then you go to the design firm. Design firm, you go to design department. So you ask them, do we have archive of, in chapter 1, you learn about IP, you learn about copyrights, you learn about the technologies. So you go to the design firm, or design firm here can be external, can be your vendors, can be your suppliers. So you go to the design department or design firm here. You go and ask them, have you ever designed a water rocket before? What are your experience in these water rocket projects, for example? Okay, then you gather all the designs. Okay, like in your quiz number 2, quiz 2 and 3, right? You build the morphological chart, you build the variation designs. So you go and dig the information from the design department. So design number 1, number 2, number 3, number 4. Same as your quiz number 5 also, right? You go and study what are the available designs out there. Then you go to suppliers. The suppliers will be focused, the main keyword in your essay, question 4. When you mention suppliers here, we focus on raw material, right? Raw material or services, right? So back to your water rocket projects. You elaborate. The input from suppliers will be on the availabilities of materials, and maybe from their contacts, they know somebody is doing water rocket projects. They will give you recommendation. This plastic bottle is the best for these water rocket projects, or they use this kind of screw. They use this kind of valve, pressure valve. They use this kind of tape, glue, and so on. Right? And usually, this company, they will give you some info about the competitors sometimes, because competitor usually producing the similar products. So they will tell you, although in their NDA, non-disclosure agreement, NDA, means they cannot tell you what company. But as you have a closer relationship with the supplier, you can dig more information. If your supplier is your best friend, then sometimes you know lah. You know who is your what your competitor is doing actually. Okay. So managing your relationship with your suppliers is important when you work as a project manager. R&D is your research and development team. Research and development team and design firm is a bit different. Design firm is more on the design, more on the features and all these things. R&D is more on the new technology. R&D is research and development. You can find the similar technology archive. Yeah, this is internal. This is internal R&D, research and development department. So the keyword for R&D is a new idea, new technologies. All right. So you go to R&D, ask them, can you help me to do some research about the new ways of doing water rocket projects, new ways of launching the projects? What about the mechanism? Can you help me to design, come up with new ideas in releasing the water rocket? Okay, or how to maintain the pressure? Can you help me to design the valve and so on? Okay, so R&D is more on the design. We do not reinvent the wheel. Understand? We do not, the standard parts, we do not go and redesign it. For example, cars, we don't reinvent the wheel. We don't reproduce new wheels and all this. We just buy from the suppliers. So the R&D, again, the keyword in your essay is a new design and the word new design, new technologies that develop internally in your company. Okay. Next one is customers. So you gather survey in your chapter quiz number 4. You go and read chapter 3. So there is a survey inside the process. So you ask question, you're assisting customers, you send out the survey and you ask question, and then you do rating, all these things. Okay, how they use the water rocket previously, whose brand, what kind of brand you use in the previous, all these things, right? Customers is the one that give you the requirement. So you go back to the customers and you confirm what really they want. For example, your water rocket projects. Customer side only give you 2 requirements. One is to launch from one side of the basketball to another side of the basketball court. And you should be able to adjust accordingly, either by pressure or amount of water or angle. according to the range that defined by the customers. Okay, so this will be your objective lah. Your objective, your project objective. Next, new technology. New technology is external. From customer, new technologies, competitor, this is an external factor. So new technology means you need to aware of the latest technology available out there. So for example, your water rocket projects, you do research, and maybe during this time there is a new maybe plastic bottle come up, a new design of the water bottle body features by a certain company, or there is a pressure pump, electronics so cheap that you can just loan from your friend. So these are the new technologies that help you to achieve customer requirement for the idea generation. Because with the new technologies, you can generate new ideas. Then the last one, competitor. Competitors, why we go for competitors? Of course, you don't go and directly ask your competitors. In the industry, let me ask you a question. How does the BMW or Mercedes or Audi, all these premium car, come up with a new design? Right? How does Apple or Huawei come up with their new phone design? How does this Sony come up with the latest technologies? Well, what do you think? How you elaborate on competitors? How they get info for idea generation? Of course, you don't go and ask directly your competitors lah. They won't tell you one. How? Customer, you already elaborate. Don't repeat the points. I mean, when you answer the question in final exam, don't repeat what you write for customers in here. It consider one same point. Like for example, idea generation. You can write in what 3 paragraph or 5 paragraph, but focusing on idea generation. Or you can put all the points in one very long paragraph, because you're elaborating the seven input there. Means at least you have 1 line for process, 7 line for input, 1 line for output. 7 about 9 line, like 9 sentences in 1 paragraph. Okay, so how do you competitors, how you elaborate on that? We do benchmarking. Of course, there are some detailed slides on that one. So later you read the rest of the slides. Okay, I just elaborate and tell you how to do it. So for competitors, why do you think or if you watch maybe another sensitive question, because we have someone from China. Why do you think China can be a great nation within 10 years time? 10 years ago or 10 years ago, China is considered as a third world. Right? 10 years ago, when you bought something from China, or somebody mentioned this one from China, what is your impression? The product is easily broken, cheap, right? And you can buy in bulk. But nowadays, if you see product from China, you have a different perspective. It's no longer cheap. Yeah, cheap lah. But it's the quality actually different. The quality is no longer easy broken, but come with a good quality. Why do you think China can pick up the technology? Huh?
They've done more research
How? How?
by investigating the competitors.
What? Competitors what? Mm-hmm.
So like they investigate like why their product is always high quality.
Okay.
So they try to learn from them, like
Okay.
copy them like that.
Yeah. You mentioned the keyword copy. Or you cannot say copy in your answer for final exam. The keyword is benchmark or reverse engineering. Okay, don't use the word copy. Use a more professional word like reverse engineering, but all the points will be inside the slides. Okay, go ahead, read. Okay, the easiest way to learn from your competitors is to buy their products, put inside your workshop, pull the customer products into R&D department, dismantle everything, go and study how they design the thing, then assembly back. This is called reverse engineer. You buy somebody the best product in the market, you go back to your R&D department, you dismantle it, open, investigate how they design, then you come up with a new design. Because when you dismantle things, you know, oh, this is how they screw the things. So that's why in the latest technologies, China also very smart already. And other companies also very smart, other countries also very smart already. Especially when it comes to electronics devices. I take an example. For example, your iPhone, if you have iPhone. If you don't know how to open the iPhone, you DIY yourself, you open, your iPhone is gone. Once you open the casing, everything was gone. There is a mechanism inside there where when you try to open it, there's a mechanism to destroy the core design. Even you dismantle it later, you're unable to trace back what is the technology inside. Okay, so this is the latest countermeasure by the industry player. Some products you cannot open one. Once you open, that's it lah. I mean, you can still see the remaining physical things, but the inside core technologies is gone. Okay. Yeah, like some of the programming syntax, all these things. Some devices or high-tech devices, once you try to hijack the information, there is a firewall inside there. Okay. Some, like for example, aircraft. Aircraft, they have a few backup system. Later, we'll learn about backup system. If anything abnormality, they will trigger signal and send back to the company. They will know actually this aircraft having problems in the real time. So when you travel in the aircraft, actually, every second, the data of the aircraft was sent back to a certain location. There's somebody monitoring the aircraft condition. Okay, so sometimes the engineer at a certain station, they know what happened to the aircraft earlier than the pilot itself. So these are the mechanism. Okay, so we have completed the input for idea generation. What is the output? Output will be the product concept. You come up with the concept. Right? So once you have the concept, you move into second process, will be the feasibility studies. Feasibility studies, later there's a slide there. Inside there, feasibility studies means you assess the risk, you come up with a more detailed engineering specification, If you read chapter 3, you come up with the house of quality and all these things. You match customer requirement to the engineering parameters, right? So like your case, your quiz 1, quiz 2, 3, and 4, you come up with the variation of products, all right? So you have a specification like, what is the size, dimension, and all these things. So later there's one specific slides for feasibility studies. What is inside there? So the output will be performance specification. This one. From product concept, go through these feasibility studies. Your output will be performance specification. Performance specification is how it operates in the real situation. Okay, performance specification. So there's a detailed explanation on this one later. Okay, so once you have all the specification, don't write product specification here. This is idea generation, output is product concept. But if you accidentally write product specification in here, it's wrong. Means your output is wrong already. And okay. So same is the keyword. Don't use the correct keyword. After the performance specification, you go to the third process, which is rapid prototyping. Rapid prototyping is the highest elaboration component or highest marks between the 20 point. Why? Because inside rapid prototyping, you have 3 things you need to elaborate. What I mean by rapid prototyping? Rapid prototyping is an integration process that producing a product. The first product is called prototype, or we call it preliminary design, or preliminary products. So inside there, you will come out, you will have these 3 process, and you see the arrow. The arrow is interrelated. This will be the careless mistakes usually in the final exam answer. You will be so unconsciously, you will draw arrow pointing down. So remember this process, you have double arrow. Double arrow. So you have three main process inside here, like internal processor here. Form design, functional design, and production design. What are the keywords that we're looking for? Form design. Form design means the features, the one that you can see, the shape. Okay, the keyword is shape, the features. Functional design is how they perform or how they operate, the operation, how they function. Okay, so when you elaborate points, don't repeat the same word. You need to elaborate. Like for example, functional design. You elaborate, don't always repeat the word functional. You need to tell me what do you understand about the functional word. Okay. Then the next one, production design. Production design is you look into how you manufacture it, how you fabricate it. Okay, so back to your water rocket application. During rapid prototyping, you come up with the form design, the shape of your water rocket, and the launcher, the shape of your launcher, how you put it, is it stable, not stable, all these things. Functional, it should be able to shoot from one point to another point. It should be adjustable to shoot at the middle court and so on. It should be able to function in that particular things. Production design, production design means you come up with the way you assemble it, right? From raw material, how you cut it, how you glue it, how you make into a full assembly. Okay, there will be one process for water bottle. There will be one process for there will be one production design for water bottles. Water rocket, there's one production design for launcher. Okay, then you combine, it become one complete product. Okay, so during this process, the output, there are 2 output. There are 2 output from rapid prototyping. One is design spec. one is manufacturing spec. Okay, design spec, manufacturing spec. Don't confuse between the two. Don't put the wrong one. Functional design, form design, they come out is the design specification. Production design here, from production design, they come as manufacturing or delivery specification. Product design do not come up with a design spec. So don't confuse between these two. These two, it will go into final test or pilot run, or pilot run and final test. Means you test until it fail. Okay. So for example, your phone, you'll do drop test. Do until like maybe 1,000 cycle. Then you will see what happened to the phone. Okay. So let's say 1,000 drop from 2 meters, right? Or waterproof specification. They will drop the phone into a water tank. They will drop it, do it for 1,000 times, for example. So if it drop into water tank and after 1,000 times, there's no water leakage inside there. So during the promotion time, they will mention water resistant grade what. When you buy phones with water resistant, they will tell you this is water resistant according to what specification. Something like that. Okay, after pilot run, you come up with the final design. Process plan means you do alteration in your design. Because during test, you know what works, what doesn't work. What is the weakness of your products? Then after you confirm, then you launch the products. This will be the process. Okay. Now during your final exam, by elaborating the chart won't give you marks. You need to apply to the scenario. For example, one semester I asked about milk products. You are the project manager. You need to come out with the new milk products. You use the same chart, but apply to the milk products. Like just now, when I explained about this chart, I use water rocket projects. You need to link to the statement or condition in the question. Okay, so previously, when I asked about the milk products, one or two students out topic already. They are so focused on the container of the milk. Wrong already. Container packaging is one part of the milk products. Only one part only. But you need to focus on the milk itself, the flavor of the milk, how you storage it, all these things. You need to go to that, not on the container, not on the plastic container, the packaging, not that, because the question asks you about the new milk products. Okay, so need to be careful on the question. Yes. Yes. You focus on the milk. The milk. The keyword inside there, the question. They mention focus on the milk products. So milk product, you spend lots of things on the milk itself, on the flavor, on new technologies, on how you store the things. You have to link to the milk. Don't spend too much time writing about the external things. Okay. Yeah. You elaborate the thing here. Rapid prototyping here. Like for example, milk. Form design. Form design is the packaging. Or the milk phrases, in physics, we have gas phase, liquid phase, and solid phase. So can you can elaborate on that? Of course, gas is not liquid because normally the normal consumer idea about milk is in liquid form. Okay, so form design, how you maintain the liquid form. Okay, so in Asia, in hot weather country, no issue. What happen if your products need to sell to those in the North Pole, South Pole, very extreme weather? Can you maintain it or not? For example, right? So the favor functional, in the question you mentioned already. Functional is what? What is the benefit of drinking milk? You need to elaborate a little bit, like some common sense. So if you add in new vitamins, new favor, can you enhance health or not? And your product enhance health. Okay. Production, how you sterilize the milk and so on. Okay. So you need to think about it. Okay. Okay, so there are lots of info in my slide. I already explained. So the detailed one, you read through the slides. Okay. So idea generation is what. So during idea generation, for example, this company, perception map, they come up with a perception map. So they do research. For example, this cereals company. So they do competition. They do analysis on the competitors. So they come up with two parameters: nutrition and taste. Nutrition and taste. So this at the middle is a neutral. So the one on the left is low, the one on the right is high, on the top is good, on the below is bad. So these are the products names that accordingly, for example, rice creeper is bad taste, low nutrition. Cocoa puff is good taste but low nutrition. However, for these Welties or cellos, they are high nutrition but in the bad taste. If you have this analysis, what is the new products that you have chances to sell? Yeah. There's no competitors, there's no product in the market that fall into high nutrition and good taste. This is a room of marketing, or this room of business. Okay. So this is the explanation of how the company go into high nutrition, high taste. They put in honey, they put in nuts, they put in apple cinnamons version in the cereals. Then they go into high nutrition, good taste here. Example lah. No need. No need. No need. You do benchmarking. So this one already explained. One of the input there. You do benchmarking. So benchmarking is so and so. It means you find the best class in the market. Then you make improvement based on the products. For example, American Express, they are known for flexibilities in payment, very quick payment. You show the card, you can just go. Disney World, they are famous for their employees' commitment. Employee commitments here means once you walk into Disney, you will feel happy. They will make you happy. They will serve you. They will make sure you are entertained. You see the staff in the Disney World is very happy one. They will act happy because it's their job to entertain you. Federal Express for speed. FedEx, they are famous for speed. McDonald's is consistency. Every time you go into McDonald's, the food is consistent. The size, the expected flavor is there. And so on. Reverse engineering, I mentioned. You buy competitors' product, you go home, dismantle it, look at their technologies. Okay. For example, Ford. Ford use this approach for their Taurus brand. They access 400 features from their competitors and enhance more than 30 of them. Okay. Including they use the Audi technology. They use the Toyota technologies. They use the BMW technology. Okay. So all this you read. Feasibility studies consists of three things. Feasibility studies. When you elaborate, you need to mention market analysis, economic analysis, strategic analysis. So the rest elaboration is here. You mean here, right? Later. We are now here. We are now here. So when you discuss about feasibility study, don't straight away jump into here. You don't confuse me. You confuse me, I will just skip to the next paragraph. When you explain in sequence. Don't jump here and there. Okay. So feasibility are here. You read all these things. What are economy? What are the strategic analysis and so on. Of course, when you elaborate, you don't need to put in all this information. I just want you to explain what you understand about the process. Okay. So maybe feasibility studies, you mentioned the three important process strategies. Three important analysis. What you do in this process? What happened in this process? Okay. Okay. Now, performance specification is a written for product concept that pass feasibility studies and improve for development. What they do, they describe the products, the function products, what the product should do to satisfy customer needs. The one I highlight in the blue, this is the keyword that we expected for performance specification. Performance specification is what the product should do to satisfy customer needs. Yeah. So performance specification is a bit different from design and manufacturing. Performance specification is a general idea. What should it perform? Okay. Now, for example, water rocket projects. The performance specification for your water rocket projects is what product should do to satisfy customer needs. What's your rocket should do? It should able to fly from one end to another end of the basketball court, and it can able to launch according to customer needs. For example, it should able to land at the middle court of the basketball court. It's a description of what customer want. If you pay attention, in the statement, there is no numbers, there is no engineering specification inside there. It's just what the customer want. Okay. Of course, you say, can I put in the numbers? Can. The numbers will become after this process. Rapid prototyping, design spec will be numbers. Manufacturing delivery specification will have numbers. Okay. So it's like a big what you call converge filter. So as you move from the top to bottom, then the specification will be very, very narrow or micro managed already. Okay, rapid prototyping, this one you read. Rapid means you do it very quick. So form design, all these things you read. Okay. There's one technical word here, concurrent design. Concurrent design is you do things in a parallel process. Means you have a few production line go parallel, and then at the end of the process, you assembly the products. So this one you read. Form design is like form design. When you write form design, don't always repeat the word form. Try to use the word aesthetic. Okay, form is another word, use aesthetics and so on. Is the how the product looks, form design. Apple products, all these things. So, like for example, form design, other than looks, what are the features? For example, the exhaust of Mazda, you have a different sounds if you know about cars lah. Then the gear shift level, the grip is different. Then the seat and window arrangement also a bit different. The way they design the seats here, these two seats and how the window come out and how the roof come out from the back. These are form. Functional is how you meet a performance spec of fitness. Okay. So these are the three keywords that were expected in your elaboration for performance characteristics: reliability, maintainability, and usability. Okay. So you mentioned these three in the performance, in the functional design. You mentioned these three. Reliability, what is reliability? Reliability is the probability of the function, right? Of the intended function. For example, this hair dryer. You have a girlfriend, then this is their trophy lah. They like to use this kind of things. Okay. So, like for example, Dyson, they guaranteed a certain function for a certain period of time. Like if you are in the cars, they will warranty you for a certain period of time, like 5 years free services. You will able have no issue for that one. Right. Okay. So reliability also always linked to the word warranties. Warranties. Okay. All right. Under functional design, there's one equation. There are two equations that you will learn and will come out in your test 2 next week. It's called reliability. Reliability is how well your product can function. The first equation for today. Reliability of the component. If you this formula will be like the one you learn in your electronic design, teach by Dr. Zuraida. Okay, if you put your resistor in series, you use this equation, right? You multiply first resistor to second resistor, third resistor. Okay, so if your product is your component inside your products is a series form, then you use this equation. R1, R2, R3 until the last one. Okay. Now it's there. So, for example, how you apply this one? If two component parts are required and each have reliability of 0.9. 0.9 means 90% it works most of the time. What is the, okay? So this is the thing lah. If two components parts they are required, usually we join the parts like this, right? Then you draw this diagram. So for test 2, remember to draw the diagram, how you join the component. So in this case, it mentioned 2, so you draw 2 parts joined together in series. Usually you start with series. Okay. Short break. Okay. We have a short break. We stop here. But what? Let me explain this one first. So how you apply the formula? So formula will be R1 multiplied by R2 because here only have two components. So 0.9 multiplied by 0.9 the reliability will drop to 81%, 0.81. You press calculator, 0.9 multiply 0.9, you get 0.81. The answer reliability of the assembly process, assembly product will be 81%. Okay. Okay, we stop here for a while. Maybe 5 minutes break. 5 minutes, okay. 9:10. Yeah.